Welcome guys to lesson 1 in the drawing component of the Pulley project. In this lesson, we're going to try and get through as much content as we can, but I'll probably try and limit the video to around 45 minutes to an hour, and then we'll split up any other content that we don't get through into subsequent lessons. I'm not too sure exactly how long this will take. Back when I was teaching to face-to-face class of about 20 students, might take 2 or 3 sessions to get through the content and then help each student along the way. So we'll just see how we go and take our time. So in this project, it is very important that if you haven't already completed the Pulley model, or if you want to skip the modeling aspect of the project and just focus on the drawing elements, you can go to the link in the description below and you can download a SolidWorks 2022 version of the Pulley model. You can then use that Pulley model to create these technical drawings, and that'll just put you on the same foot as everyone else that has already created the model with us. So what I'm about to show you on screen is an example of the drawing set that we're going to create. There will be some elements that are different, like drawings, like modeling. There are always different ways to do things. Okay, there are standards out there, international standards for communicating drawings. But look, as a product designer of 15 years, it's been very, follow the standards and the guides and geometric dimensioning and tolerance and guides as closely as you can. But what you're trying to do is just communicate with the supplier. Okay, communicate the important points. So as much as there are guidelines, regulations, okay, standards out there, I'm not here to teach you those. I'm here to teach you how to put your 3D model on a 2D drawing and how to do that effectively, and some tips and tricks along the way to make it quick and painless to do. Because let's be honest, everyone likes designing. Not everyone likes doing drawings. So you want to be able to do it quickly and with as minimal pain as possible. So I'm going to show you how to do that. Let's get into it. So I'm just going to flick over now to, so just showing you now where we're at with the product, with the project. We would have already done the model of the 7 parts of the Pulley, sub-assembly, put some nuts and bolts in there, and got everything fully defined in an assembly file. So that's where you should be. And if you don't have this file to start, go and download it from the link in the description. What we're going to create is this drawing set. Now, this is the last version of the drawing set that I created for my students. This one was done back in 2011. So it's had a decent life. Berkner in the top right-hand corner, that's my old freelancing logo. That is my name and my Hotmail address. Okay. But the drawings here, we're going to just create a replica of these. It's 11 pages of content, and if we press the pages icon here in PDF, we can flick through them all and you can see quickly what those are. The general layout that we'll be working to is having a general assembly on the front page with a bill of materials on the top and some general views. We will have standard 3 views and an isometric view on page 2 of the assembly showing overall dimensions. We will have an exploded view showing how our parts come together with a couple of annotations and route lines. We will have a drawing for the sub-assembly. The sub-assembly, again, showing some of its dimensions. We will look at configurations to do the before and after of the pivot pin, and again, do a second bill of materials for that sub-assembly. And then we go into detail for each of these parts. Now, these part drawings, we're focusing on a couple of drawing views, dimensions, view labels, in some cases some annotations, and sectional detail views. We are not focusing on the materials, the production methods. Okay, that's another level of technical drawing and design knowledge that we're not getting into in this project. This project is for beginners doing drawings for the first time. So I'm going to introduce you to all the tools that you need to replicate what you can see here on screen. Now, some of those parts, as we know through the modeling, are quite simple. So they're obviously going to be simpler to create on a 2D drawing. And then others have intricate details like the engraved text on this. Okay, that's going to require a detail view. Again, we'll show you how to do those. sheet metal part. Can't remember if we've already converted our form bracket into sheet metal or not, but we will go through that process. And the pulley wheel will show you how to do a section view, detail view, and a couple of annotations. And that's going to be our complete drawing set. So let's get straight into it. This file is also available in the Google Drive for reference. So you can come to that, download your own copy at any point. You will be welcome to lay out your drawings following this guide here. I'll talk more about that as we go. Now, to start a drawing file, it is helpful to have the parts or assemblies open that you want to create a drawing of. Saying that, you don't need to open up all the individual parts. Just start with your assembly open, because that's going to be the first drawing that we might do anyway. You can go File, New, or you can go Make Drawing from Assembly. Let's press that button and see what happens. All right, so that will take us to our new SolidWorks document screen. Now, if I flick over to the novice screen here, you can see that parts and assemblies are grayed out. It's only going to allow me to select a drawing file. So I can select drawing and OK. And then our very next screen is going to open this sheet format size pop-up window. Now, this may not happen depending on your SolidWorks defaults. So here I'm going to explain a little bit about SolidWorks file types, SolidWorks document templates, and sheet formats. We already know there are two types of SolidWorks files. We have a part file and we have an assembly file. The third type of SolidWorks file is a drawing file. A drawing file, as you can see from the description, a 2D engineering drawing, typically of a part or assembly. You can do drawings and sketch something completely new in the drawing, okay, but it's only ever going to stay in 2D. And that's a pretty rare case. It's very rare that you'll do that. 99% of the time, you'll be referencing the parts or assemblies that you've already created. Okay. Now, those being the three file types, when you have a drawing file type, as you can see here on screen, our tools are very different. We have different drawing views, we have view layout tools, we have annotation tools, we have sketch tools. Sketch tools are just like in a part file. There are some differences in how they function, but they're there. Also have markup, evaluate, and some other add-ins. Now, I'm going to turn off a couple of those ones because we don't need them. Don't need add-ins. I do not need evaluate. I do not need markup. I'm going to turn them off. And sheet format, we have some buttons here to edit sheet format, edit the title block, or create an automatic border. Now, what is a sheet format? Let me explain with my drawings here. If we look at this page and we want to understand what elements are custom for the page, if we look at our drawing views here and here, okay, everything there, that's driven from those assembly files. We have let's draw some bigger lines. We have a bill of materials up the top. The bill of materials is a table that gets inserted into our drawing, and that table is referencing the model that is on that page. In this case, it's referencing the assembly file. We have a similar thing on this page here, where this bill of materials is referencing this sub-assembly that's on the page. And then the other element that we have in our drawing, which we can see the border that goes all around the page, and then our side over here where we've got some company information, we've got some information about the client and the project, drawing number revision, some scale sheet size, etc., some information about materials, 3D orthogonal symbol, and then a revision table. All of this, everything that's in the light blue color, that is your sheet format. And if we go through these pages, you can see that sheet format here is consistent throughout that entire file. There's a couple of elements that do change from sheet to sheet. In this case, our sheet number and our scale. So if I flick through the pages, if you can see it just below here, so scale and sheet. So the sheet is like page, so it's page 8 of 11. And the scale changes depending on the images, the drawings, or the files that are on that page. So for my assemblies, they're 1:1 scale. But when I look at some of these smaller parts like the washer, if I were to do this part 1:1 scale, it would be tiny on my page. It would look really out of place. Now, typically what you might do is instead of using an A3 drawing size, you might use an A4 drawing for that part if it's so small. and have it at 1:1 scale or 2:1 or something like that. But let's remember that our objective with these drawings is to communicate. Okay, so when we're saying communicate, we want to be really clear about the information that we're providing to whoever it is, work out who our audience is, work out what they need to see. If it is a manufacturer, they're producing this part, well, they want to know to what dimensions and to what shapes and forms they need to make that part, right? Without going into detail about manufacturing processes, that's what they want to see. So the light blue being the sheet format, if we go back into our SolidWorks file here, we can see there's actually nothing on this page. And this is what could be referred to as a blank or empty sheet format. There's nothing here. So if I close that file and start a new drawing again, it's at this screen here where you can select a sheet format. If you don't select a sheet format by clicking in standard sheet size and then browsing to one or selecting one already, and you select custom sheet size, that is how you can actually create a blank page in a SolidWorks drawing. So if you just want to create a blank page that, let's say, is an A4 size, so 297 width by 210 height, this is in millimeters, you press OK. We now have a blank A4 page. And if my scale is 1:1 and I do, let's say, a sketch of a rectangle and I put in my dimensions, sorry, this is in IPS, let me change to millimeters. You'll see here, 210 by 297. Okay, that is an A4 sized drawing. So that's a handy tip if you ever need to create a blank page. Now, when might you want a blank page? Let's say you're doing some concept work and you actually don't want a sheet format on your pages. You just want to print out something that you've been modeling quickly. Okay, maybe you want to create a 1:1 model or have a sketch there in front of you. Have a dimension drawing there in front of you so you can do some sketches over the top. You don't want the sheet format stuff around it. This is what you want to do, a blank page. So now you know how to do that. But for our project here, we actually want to have that detail on the page. So all this information here, we want it in our file, in our drawing file, so that it carries across to each page so that we know and our supplier knows the information that we're communicating to them. In this case, we're going to communicate to them the name of the project, who our client is, the description of the drawings they've received, the drawing number, and other things such as like the date and revision. Okay, this is important. Often, if you don't know what a revision is, well, a revision is the version of the part that you're sending them. So if you've sent one part previously, you've made some changes after some feedback or prototypes, you want to send them version 2. Okay, you want to make that clear on the drawings so that that supplier doesn't get confused with an old and a new revision. So, sheet formats, let's go into how they work and how we can create our own. We won't create our own in this project, I'm going to give you one, but let's see how they work with our files. So, to get into the sheet format mode, well, let's open a different file that has a sheet format. Now, I have created one already. I'm actually going to import it into this drawing by clicking on standard sheet size, browse, and then I'm going to browse to the one that I've created. All right, so this is our sheet format. Looks a bit different to the one that you saw earlier, but it's going to work in a very similar way. Now, you'll notice that these lines on the page cannot be selected. Okay, none of this can be selected. That is because it is part of the sheet format. If I want to edit the sheet format, what I have to do is go click on the sheet format tab here and click edit sheet format, or actually right click on the screen and go edit sheet format here. And now I'll be able to edit these lines. So I could select this line, for instance. I can see it's just a standard sketch line. It's on a layer, which is thick. Okay, so it's thickened up that line. You can look at layers and layer properties another time. Okay, but these are all these little elements here. These are just different sketch elements on the page. And then here, these are annotations or notes. In this example, this note is just the number 2. Okay, but that is something that we could change if we wanted to. Down here is our main information, and you can see that there's a couple of items which are actually change color. And just to make it really clear, I'm going to change the color of some of the others so that we can also identify them. Okay, now I believe I've got everything here in blue, which needs to be. So all the blue elements, where you can see they've got, let's say like they're essentially a formula. So if we go here, $PRP sheet material, color, weight. What those elements are looking for is a value to come from a part or assembly file that is put into this drawing. When we're editing the sheet format, we can actually change those equations, those formulas, to reference something else. That is something I will show you in one of the later lessons of this project. Or more advanced, I might show it in a more advanced class, okay, for drawing setup. But the main thing that I just want to get across is that everything that is black is static. Okay, it won't change, it won't move. And so when we create multiple copies of this page in this drawing file, we will end up with all of that black information being exactly the same. It's only the blue elements that will change. And those blue elements will only change if, for instance, we have a different part on a different page. Well, that part number is going to change. Okay, so that is our sheet format mode. Now to exit out of that sheet format mode, we're going to click this button here or here. We're going to right click and go edit sheet. And then we're back into our normal view mode. Our normal view mode being where we're going to add our drawings of our parts. So while we're at it, talking about sheet formats, I also want to talk to you about document templates. This can get confusing as a beginner because templates and formats, and they sound like kind of the same thing. Well, not quite. I want to explain by opening up this screen here where we have a new SolidWorks document. So when you select this part here, it's going to open up a new part file, and that new part file comes from a part document template or a part template file. So with any SolidWorks installation comes default templates. And if you are using SolidWorks for the first time, no one else has used it on your computer, SolidWorks will just use the default templates. If you're working for a company that has an established engineering team, design team, other designers, they may have already created these templates and stored them on a server or on the cloud, okay, or on the laptop or computer you're working on. And those templates save such information such as custom properties. Sometimes it'll save information like the author and company details. And often it's a way for a company to keep track of their files that they create internally. All right. Now there are part templates, there are assembly templates, and there are drawing file templates. The template is different to a sheet format. The way that it is different is that when you open a template, that template file, so drawing template, will include a sheet format already assigned to it. You can have multiple sheet formats with multiple document templates. And where that comes into play is when you click on this Advanced tab on the new document screen, you can see here there are folders. These are tabs, but these tabs actually correlate to folders that I have in Windows Explorer. And within those folders, my folder of A3 drawings, I have 4 different drawing templates. So let me just zoom into that to make it a bit clearer for you. So I have an A3 drawing folder, A4 drawing folder, and a document templates folder, 2 Toby templates. See 2 Toby stuff on my page or his website for more SolidWorks and 3D modeling tutorials. So within A3 drawings, I have A3 drawings for moldings, for assembly files, for machined parts, and for general assembly parts or general parts. So I have 4 different templates, and each of those has a slightly different sheet format. And the same in the A4 drawings. Included here as well is a blank template. Okay. Now, one of these might be off. I might have to go in and edit that one. Fix that up later. Document template files. I have a parts template and an assembly template. This is from my workplace, so quad lock. Anyone starting a new part file is going to use the same part template. Same thing for assemblies. But drawings, well, that'll depend on what you've created and what its purpose is. Okay. So if let's say I look at an A4 drawing here, a general template, and I press OK, that's going to open up with this sheet format that you can see on the screen here. And if I right click, go edit sheet format, you can see how this looks. Okay, so what happens with the sheet formats? If I start a new drawing and I'm starting a general drawing, A4 file, that is a drawing template file that I've opened up. Within that template file is this sheet format. The sheet format can be found by going right click properties, and the sheet format being used is this file here. So this is the address of that sheet format. Okay. And then what's so great about that sheet format is when I want to create multiple pages or multiple sheets in this one drawing file, I can press here add sheet, and it's going to create a new sheet with exactly the same sheet format. So that'll carry on across all pages that I add into this file. I don't need to manually add that sheet format to every single page. Just do it once and it's there. So one of the important things with your sheet formats is that you want them set up before you create your drawing set. Okay, if I create a drawing document and I've got, let's say, 10 pages in there or 11 pages like we're doing with this Pulley file, if I halfway through the project decide, I want to make some updates to my drawing template, to my sheet format, I have to go edit the sheet format, save the sheet format, and then go individually to each of these pages and press the reload button. And that's not something you want to do. So definitely recommend always creating your sheet format, editing it, saving it, setting up as a document template first before going ahead and creating your drawing files. So it's at this point that it would be good for you to go into the link below to the Google Drive and download the sheet format file that I've created here. Because I'm not expecting you to create your own for this project, but I want to show you how to import it, download, import, set it up in your own file to then be able to use it across your drawing set. So what you need to do is click on the link. We'll just use an incognito window here. We're going to copy the address that I've given you, and it is this Pulley A3 drawing general.sld.drt file. That is a sheet format file. You want to download that. I'm going to save that in my downloads. Okay, and then to open it up, let's just close this file, and we're going to start a new drawing. Now you can select, even if you're a novice here, you can select drawing and press OK. And when you get to this point here, we're going to click standard sheet size, browse, and then you can browse that file that you downloaded. Now, ideally, you will have put that file, let's say, in your folder with everything else. In fact, why don't we do that right now? I'm going to cut and paste that into my project folder for my Pulley. So it's going in here. Once it's there, I'm going to select it, press open, and press OK. And you can see now it is in our drawing file. Now, just in case you did want to make changes before you go through the drawing set, we're not going to look at any detailed changes, but something like your logo. Right, you can edit the sheet format. We know how to do that now. Right click, edit sheet format. You can type in your details. So just to double click and type, or let's get this into millimeters. Let's say I want that to be 5 millimeters. And I'm just going to put it here. It's already bold. Let's get underlined as well. Okay, so let's just say that's my logo. Perhaps you want to change your company information. Okay, you could do that as well. Perhaps you want to change any of the notes here or scrap them entirely. You can go edit sheet format. You can select this whole thing and press delete. Okay, you could do that if you want to get rid of them. But to save those, there are two things you need to do. First, you need to exit the edit sheet format. So we get out of that. Second, we go File, Save Sheet Format, and then you need to give it a name. So here, I'm going to name it edited so we know there's a difference. Okay. Now the edited one has the bigger logo. So just watch that carefully. If I click add new sheet, it's going to add a sheet with the old sheet format. All right. If you want to keep that sheet format here from page 1 consistent across the rest of your pages, you need to right click on sheet, go properties, click here for browse, and we need to browse to that new file that you just saved. All right. So going to go into here, and it was the edited one. So I'm going to press open and press apply changes. Now we won't notice any difference on this page, but something has been deleted there. But what we will see is on any subsequent sheets, Okay, that logo carries across now. So sheet 1, 2, 3, they are all the same, except for some reason that little icon wasn't showing up. It's there now, okay? All right, so that is how you can edit and save a sheet format. Now, one of the really fancy things, I'm going to go back to the original drawing. Okay, browse, content, Pulley. All right, let's stick with this drawing file now and let's save it with the rest of our Pulley files. Pulley drawing set. Now, the name of the file, I'd like to say it's important for this project, not important, but for when you're doing work with a client, the name of the file usually ends up in the description, okay, or the title of the file, depending on how our links are set up. You will see it at the top of the screen here where it says drawing 19. That is where the name will stand. And then when you print your file, so if you save as a PDF, for instance, by default, it will use the name that you set here. So you can change that, of course, but if you know what you want to call your drawings from the start, it does make sense to put that in when you save your file. Okay, now that we've covered off the basics of sheet formats, document templates, I know it's a bit dry, but we've got that out of the way, we can now move on to starting to bring in some of our drawing views into our file. We're going to start with the general assembly, work on the exploded views, some basics, and then we'll do the individual parts as we go. We'll actually get a bit easier as we progress through. Our first page, if we remember our first page here, I will have to get rid of the drawings somehow. On our first page here, we've just got a couple of a front or a section view and a side view, but our first page, what we're actually going to do is this one here, where we've got standard 3 views and an isometric view. So in SolidWorks, this is what we do. Assuming you already have your assembly open, now to see if it's open, I can Control Tab between my files. I'm going to click on View Layout, Standard 3 View, and then we can see Open Documents. Now, if you don't have your assembly open, it won't show here. You can browse to that file. So you can browse, find your General Assembly, and then press Open. We're going to click on the General Assembly, and then I'm going to press the tick. Let's see what happens. Okay, we get standard 3 views into our file. Now, these 3 standard views have come in at what's called a three angle orthogonal. I have to look it up. Third angle. These standard 3 views have come in at third angle projection. Now, how do we know? Well, third angle and first angle are 2 different drawing types. Often seen, you can see the difference between them in architecture and then, let's say, product design drawings. Typically, I think architecture is first angle projection, whereas like SolidWorks product design drawings, third angle projection. We can see here third angle projection. What that means is we get a front view, a top view, and then a side view to the right. And those are our standard 3 views. Now these standard 3 views are special compared to some other drawing types. You can create it manually, but what you'll find is the front view, which is the one in the bottom left, if you click on the box surrounding it and then you drag, you can see it is linked to the other 2 views. So the top view and the side view will follow this one around. You can unlink them. To do that, you can see like this side view here, I cannot move it up or down. I can only move it side to side. But if I want to move it anywhere on the page, I can right click and go alignment, break alignment. Then I can drag it around. If I want to realign it, I can go right click, alignment, default alignment, and it will once again put it back in line with the original view. Right, so there's a couple of other cool things that come with using the standard 3 views. So firstly, they share what's called an appearance type or display style. We're just going to zoom into the feature tree here. Just move my head out of the way, and let's get these 3 drawings over to the side. So your display style is here. You can see that there's 5 drawing views. Now, 5 display style types. Now these types, we've seen them before. So if you remember in our part or assembly files here, at the top of the screen, you can see this drop down. Shaded with edges, shaded, hidden lines removed, hidden lines visible, or wireframe. Different drawing types, different display style types. The same can be done with your drawings in an assembly. So if we click on our front view of our drawing, we can change the display state to shaded. And that's going to change it for all the views connected from the first view of this linked 3-view drawings. Now you can change them individually, much like you can change the alignment. If you click on one of these projected views, you can then see here, uncheck use parent style, or just simply select on a different view type. Okay, that will change the view style of those parts. The standard 3 views also can share scale. They can share other options, and the side view and the top view, what you actually see in those views is related to this very first view. So the first view that we brought in using that tool, standard 3 view, will by default be the front view in your assembly. So if we Control Tab back to our assembly file, press the space bar, press front view, this is the front view that we will see when we use front view in the drawings. Okay. Sometimes though in your drawings, like we can see in our drawing here, okay, we've actually repositioned it on that page, okay, maybe slightly outside standards, but to fit it better on the page at a 1-to-1 scale, we want that top view going sort of horizontally across rather than straight up and down. So we've made our first view the side view. To do that here, we're going to click on that front view and go into the orientation bar and just click on some of the other views to see what we can get. So if I click on the left, I get this view here where I can see the nuts and the bolts. Or if I change it to the other side, I just get the bolts. All right. Where this is also very useful is when we do, like let's say an isometric or a 3D view, projected view, that's connected to these shots. So this time I'm going to select projected view on the toolbar. I'm going to scroll down and you can see when I move my cursor over these views, I get a little preview box or a bounding box that comes up. So you don't actually have to click on a part to do a projected view or anything like this. You just click on the view, the box, the bounding box. I'm going to click on the now side view, and then I'm going to drag my cursor. So I've just clicked, let go, and I'm going to drag my cursor, and you can get a preview of what that looks like. So this is projected view. As I move my cursor around, I will get different previews of what the drawing will look like at those angles. Now in this one, I'm going to do an isometric view, so I'm going to click and drag over on that side. And now again, if I go back to the original view, the front view, and I change the angle, you can see it's going to change all 4 views now, not just the 3. And the same thing will happen with my display styles if I'm using a parent display style for all 3. Okay, cool, hey? So what I'd like you to do is replicate this page. So to do that, first, and reposition, work out where we need some space, we're going to have to change the scale of the sheet. So the scale, you can see it in a few places. At the very bottom of my screen, I'm just going to lift this up so you can see it. We can see here it says 1:2. If I click on that little drop down, I can click Sheet Properties, or I can click here and change the scale very quickly. So if I click 1:1, that changes the sheet scale to 1:1. Sometimes that doesn't work. It's weird, I know. But if it doesn't work, click on Sheet Properties, and then you can manually type in the scale here. And this is where you can also put in scales that aren't standard. Not advisable, but sometimes you need to do that for communication purposes. 1:1 in this case, and we can see how it's changed all those drawing views. Now those drawing views, their scale can also be controlled in the property manager on the left, where I can use a custom scale that's independent of the sheet. So the sheet is 1:1, but I'm using a custom scale for this drawing view. Again, not advisable. Best practice, use a consistent scale throughout all your drawings. Next best, use a reasonable scale like 1:1, 1:2, 2:1, etc. in as many drawings as you can. Now this product, fortunately for us, is made at a size which works pretty well on an A3 page, standard A3 page. And wouldn't you know it, when the students have to print this project and submit them on actual paper or PDFs, they can use standard page sizes and standard paper. So there was some reasoning behind that. I want you to replicate what you can see in this with the layout. Now our sheet format's slightly different, but that layout should still be able to work. Make sure you are saving. All right, so that should be a pretty quick process just to get those 4 drawing views done. That's all you're doing for now. We're going to go through the drawing set in stages. So what we're going to do is try and lay out all the drawing views first across all the pages. Then we'll do the detailed views and section views. And then at the end, we'll do all the dimensions and annotations. That way, we're not jumping around too much. We're actually learning step by step how to lay things out, set things up in the right way to use those skills efficiently as we go through. So once you've done this page, I want you to create a new drawing. So we're not doing a new file, we're just adding another sheet. So you go down to this icon here in the bottom left, click Add Sheet. If you do get this warning about blocks with duplicate names on other sheets, normally you can just say yes or no. It does not matter. Okay. Unfortunately, there's no option to dismiss that warning by default. On this page, I want you to create just a side view. And then I'm going to show you how to do a section view. And that's going to be the end of our first lesson, I think. Now, we don't need a standard 3 view on this page, although you can use it and then delete these other views. That is one way to do it. What we actually want is just one view. Now, if you ever just want to put one view in a drawing, the best way to do it is to use model view. So I'm going to click model view. I'm going to click GA01. I'm going to double click it, and then I can actually get a little preview of the size of that drawing view. Now I can see that that's kind of the front on view. Okay, I want the side view. So in my property manager, I'm going to click to the side. I'm going to scroll down, sheet scale selected, that's okay. By default, it's put my sheet at 1 to 2. That's fine, I'll drop the view and then I'll change the sheet scale. So there's the drawing view, and then I click on sheet scale 1 to 1, and I'm just going to leave this one down here. And now for the section view tool. So again, on our view layout, we can scroll across and click section view, and it gives you a description here. So we're going to select a cutting line and place it on the view. So you can see here the options on a cutting line. Normally, the 2 standard ones you use are like a vertical line or a horizontal line. And the arrows point in the direction that it's going to show you a section of. So your section might change depending on which direction the section faces. Let's do a vertical one. And then what you want to do is find a nice midpoint to make that line coincident with. Now you'll find that as you hover over any of these circular points here, the center point of those circles will come up as a point that you can drop it on. I'm going to drop it here, and then the section view pop-up comes up. We're going to leave auto hatching on. Now flip direction is where you can see it's going to flip the arrows in the direction that it cuts. Leave that unchecked, press OK, and then we're going to drag. So I'm just dragging my cursor over to the right and click. Now the view label down here, section AA, is default, as is the letters on that section sketch. The hatching, if we click on this drawing view, that's controlled with the properties of the section view. We can change some of these elements. So a partial section, not really useful in this example. Slice section, okay, so slice section, that's only going to show the parts that you actually cut through. So anything that is like just behind that face, it's going to hide it. All right, this is why we can't see, let's say, this hole through the bottom here, which is where this hole is, here. We can't see it when we're doing that slice section. But we'll leave that off. Auto hatching we want on, but we might want to set randomized scale. And what that will do is change some of the proportions or angles of that hatching to work better with our drawing view. Scale hatch pattern, we'll leave. Emphasize outline can be useful. I'm going to tick that on. The rest of it I'm just going to leave and then press OK. All right, and we are done. And we're going to save, and that's where we're going to cut the video for this first lesson. So we've chatted about document templates, sheet formats, how to download and import a sheet format, how to do some basic edits in a sheet format, and then we've looked at the very start of bringing in drawing views. So bringing in a standard 3 view, a model view, a projected view, and doing a section view here. Now, in our next class, we're going to continue to build out the rest of our views. So we'll do one of the sub-assembly, and then we'll start doing all the parts. Then we'll look at creating the bill of materials on that first page. And once we've done the bill of materials for that page and the sub-assembly, we'll work on exploded views, and then start to work through some configurations and other detailing before finally getting into all the dimensions. So good first lesson. Hope you enjoyed it. Follow the links or the playlist to go to the next class. I'll see you there. Thanks. Thanks for watching this video. I hope you found it helpful and found something new to enhance your SolidWorks skills. Don't forget to subscribe to Fully Defined for more tutorials, tips and insights from a certified SolidWorks expert. Hit the bell icon so you never miss an update. If you have any questions or topics you'd like me to cover, leave a comment below. I read all comments and love hearing your feedback. Remember, with the right skills and tools, you can turn your design dreams into reality. Keep modeling, keep learning, and always fully defined.